Hello, everyone. My name is Manuel Trummer. I'm from Cornell University. And in this talk, I'm going to discuss about topics at the intersection between databases and natural language processing. In the area of natural language processing, there have been several exciting advances over the past couple of years. In particular, we have seen the transformer, which is a neural network architecture that has several advantages over prior approaches for text generation and analysis. One of them being that it is more scalable, and that has in part enabled the creation of large pre-trained language models such as GPT-3, which feature hundreds of billions of parameters. And those pre-trained language models can be specialized for new tasks with relatively little overhead using a process called fine-tuning. Now, in fine-tuning, we start with a randomly initialized neural network. Then we train it in an expensive pre-training step using a task for which large amounts of training data are easily available. For instance, trying to predict obfuscated words in a text document. Now, this pre-training step happens once, but the resulting model can be easily specialized for other tasks, such as trying to translate natural language questions into corresponding SQL queries. The advantage of pre-training is that for specialization, we only need a very moderate amount of training samples and have very little training overheads compared to training everything from scratch. Pre-trained language models have already been used in the context of databases. Typically, those approaches focus on the interface between user and database, for instance, by enabling natural language query interfaces. Instead of that, I propose to use them in order to improve performance in data processing by analyzing text documents such as the database manual, blog entries about database performance, forum discussions on forums such as DBA Stack Exchange, schema element names, or query fragments, because this seems like useful information for automated tuning tools that make decisions such as query optimization, physical design, or parameter tuning. I outline multiple use cases in the paper. In the following, I'm going to focus on parameter tuning, because as we all know, database management systems nowadays have hundreds of tuning parameters with significant impact on performance, and the default settings are often suboptimal for specific workloads. So here the idea is to try to extract useful information about parameter tuning from text documents. Because if you take a database systems like Postgres, for instance, you typically find a lot of text documents with corresponding tuning hints. For instance, if we look into the manual, we will find the tuning hint over here, which recommends to set the shared buffers parameter to about a quarter of main memory as a starting point. And in my experience, this tuning hint often improves performance significantly in practice. In order to use this tuning hint for automated tuning tools, we would have to translate it into a formula like the one that you see here, as stating that shared buffers should be about 25% of main memory. And this formula is relative to the total amount of main memory available on a specific system. You might also have tuning hints that propose absolute values, such as the one over here, which translates into the formula that you see here. And those are only two examples, but for Postgres, you would find thousands of websites which contain specific tuning hints for certain scenarios and workloads. I built a simple prototype of a system which extracts those tuning hints automatically. So if we have a text document like the one that you see here on the right-hand side, you would start by trying to detect snippets within it that contain concrete tuning recommendations, like the one over here. Now, this tuning hint is incomplete. It recommends a value, but it doesn't actually mention the parameter it refers to. So we might have to extract relevant context, which in this case is the name of the parameter, which appears a couple of sentences before. And once we have both the context and the tuning hint, we can translate it into a formula, which here is again relative to the amount of RAM In order to get a concrete value for tuning, we have to instantiate this formula for a specific system, and now we can set the parameter to the proposed value. However, we don't necessarily want to rely on one single document for tuning, so we verify consistency between multiple tuning documents in our collection. Now, in this case over here, we find a similar tuning hint in a different document, and that means that we probably want to add this tuning hint to the final tuning recommendations, which is the output of the system. I evaluated this prototype experimentally. The prototype is implemented in Python and based on a Hugging Face transformers library. And more specifically, it uses the Roberta pre-trained language model and fine-tuning according to the process that I described before. The target systems for tuning are Postgres and MySQL, and I'm tuning on the TPC-H benchmark. I'm also using two baselines, which is existing tuning tools specifically for Postgres and MySQL, which analyze the system properties and then make specific recommendations for parameter settings. In order to get training data for the neural networks that are part of this approach, I issued Google queries, for instance, for PostgreSQL database tuning, then automatically parsed the text from the first 10 result websites and manually labeled the corresponding sentences. I used this in order to train the detection of tuning hints and the classification of tuning hint formulas. And this is important. I used the labeled training data for Postgres tuning hints for training, and then for testing, I used tuning documents about MySQL and vice versa. So training and test data refer to different database systems, which will show us whether the system is able to generalize to tuning hints for new systems. Those are the results for TPC-H. We are comparing the default settings, the recommendations by the baselines, and this approach using automatically extracted tuning hints. And as we see here, the approach improves very significantly over the default settings, and it also still improves a bit over the baselines, which seems promising. Now, this approach only uses text documents in order to generate recommendations. I don't necessarily advocate leaving it at that, but I see this as a starting point for other tuning methods. So as part of my future work, I will try to integrate information extracted from text documents with measurements gained by executing trial runs for specific parameter settings. I also want to support more complex formulas for those tuning hints, and I want to extract information about a more diverse set of criteria. For instance, many of those manuals and blog entries, they contain warnings if certain parameter settings destroy ACID guarantees. And that's something that is very hard to find out by automated executions. But when reading the manual, we can typically find that out quite easily. And beyond the parameter tuning, there's many other tuning problems in the context of databases, such as query optimization or physical design optimization. And I want to see whether information gained via natural language analysis can be useful for some of those other problems. For instance, in a recent work that is currently published as preprint, I am trying to predict the correlations between table columns based on the names of the table columns. And that actually works quite well and could be useful for cardinality estimation and therefore for query optimization and several other tuning problems. So in summary, I propose to leverage natural language processing methods for new use cases in the context of databases. More specifically, I have proposed NLP-enhanced database tuning, where we extract tuning hints from text documents and use that for parameter settings. Thank you very much for your attention, and now I look forward to your questions.